We all know AI is changing pretty much everything, right? But it has this fundamental blind spot. See, these incredibly powerful models are trained on the public internet. So how can they possibly understand the one thing they've never, ever seen, your private data?
I mean, you've seen what models like GPT, Claude, and Gemini can do. It's astonishing. They've processed tens of trillions of words from thousands of domains. We're talking healthcare, law, coding, science, you name it. They have this incredibly vast understanding of the public world.
But that's the crucial limitation right there. They know absolutely nothing about what goes on inside your organization. Your internal documents, your company policies, your customer data, to them, it's all a complete mystery. It's a walled garden they were never trained on. So, the central question we're going to tackle is this. How do we bridge that gap? How can we get an AI to tap into the unique private knowledge base of your company, your team, or, even just your own personal files? Okay, let's make this real. Let's imagine a company, we'll call them TechCorp. Now, TechCorp has 500 gigabytes of internal documents. We're talking policies, product info, support tickets. It's basically their corporate brain. And they want their new AI assistant to be able to use all of it.
Now, you might be thinking, well, can't we just feed all those documents to the AI? And the answer is, sort of. We can, but only through something called the context window. The best way to think about this is as the AI's short-term memory for just one single conversation. It's powerful, for sure, but it's temporary, and more importantly, it's limited.
Yeah, this short-term memory is getting bigger. I mean, much bigger. 1 million tokens sounds like a ton, but when you're talking about a massive corporate knowledge base, even that is just a drop in the ocean. There's a hard ceiling.
Think about that for a second. Only 50 documents at a time. For a company like TechCorp with 500 gigabytes of data, that's nothing. So we clearly can't just stuff everything into the context window. It's like trying to memorize an entire library for a single exam. It's impossible. We need a much smarter system, a way to find the right book at exactly the right time.
So, how do we solve this? Well, the answer starts by completely changing how we think about search. What if we could move beyond just matching simple keywords and instead search for the actual meaning behind our questions?
And the magic that makes this possible is a technique called embeddings. It's a bit of a wild concept, but basically, an embedding model takes a piece of text and converts its meaning into a long string of numbers, a vector. And here's the key. Similar concepts, like vacation and holiday, end up with very similar sets of numbers. They become mathematically close. And here's where you really see the payoff. A classic keyword search for, say, staff time off would completely miss a document titled vacation policy. It just doesn't see the connection. But a semantic search, which is powered by these embeddings, understands that the intent is the same. It knows you're asking about taking a break from work, and it finds the right document every single time. It's a game changer. So here's how the process works in practice. First, we take all 500 gigabytes of TechCorp's data and turn every chunk of it into one of those numerical embeddings. Then, we store all of them in a special kind of database called a vector database. After that, when a user asks a question, we convert that question into an embedding too. And finally, we just search the database for the document embeddings that are the closest mathematical match.
Okay, so we've got our LLM. That's the brain. And we have our vector database. That's the library. But how do we get them to talk to each other and work together seamlessly? Having the right parts isn't enough. We need a toolkit to actually connect them all.
And this is where a framework like Langchain comes in. You can basically think of it as the plumbing and the wiring for AI applications. It gives developers all these pre-built components and connectors so they don't have to build everything from scratch. It really does all the heavy lifting of connecting the pieces.
What Langchain really helps us do is move beyond a simple LLM, which is kind of like a static brain, and build what's called an agent. And an agent is so much more powerful. It has memory, it has autonomy, and it has access to tools, like our vector database, which allows it to perform complex tasks all on its own. Langchain just makes a developer's life so much easier. Switching between different AI models from OpenAI or Google is as easy as changing one line of code. It handles all the messy stuff like conversation history and database connections, and it can reduce all that boring boilerplate code by up to 70%. It's a massive accelerator for building these systems.
Okay, we now have all the pieces on the board: the LLM, the semantic search, and the toolkit to connect them. So let's move to the final step, the architecture that combines all of this into one powerful, coherent system.
This architecture is called RAG, which stands for Retrieval Augmented Generation, And it's a really beautiful, simple concept. You retrieve the relevant information from your private data, and then you use that information to augment the AI's prompt so it can generate an answer that's grounded in facts. The whole flow is this elegant three-step process. First, we retrieve the most relevant documents using our semantic search. Second, we augment the prompt we're sending to the LLM by just pasting that text right into the context window. And finally, we tell the LLM to generate an answer based only on the fresh, specific context we just gave it.
And boom! Just like that, we've solved the context window problem. We're no longer trying to stuff the whole library into the AI's brain. Instead, we're acting like a perfect librarian, finding the exact few pages it needs for any given question, all without any expensive, time-consuming retraining.
So we've built a really powerful Q&A system. That's awesome. But what if a user's request is more complex than just a single question? What if it requires multiple steps, a little bit of logic, maybe some reasoning? To handle that, we need to level up our agent's capabilities.
For this, we turn to LangGraph. It uses the same building blocks as Langchain, but it arranges them in a much more flexible way. Instead of a simple, straight chain, it lets us build workflows as graphs. And this is what allows for really complex behaviors like loops and decision-making that a basic Q&A system just can't handle.
A LangGraph workflow really has three key parts. You have nodes, which are the individual steps, like search privacy policy documents. Then you have edges, which are the paths that define the flow from one node to the next. And they can be conditional, like if the compliance score is less than 75%, go back and search again. And finally, you have state, which is the shared memory that sticks around for the whole workflow, so every step knows what the other steps have already done.
So, what were the results for Tech Corp? Absolutely transformative. Manual document searches that used to take employees up to 30 minutes now take the AI agent less than 30 seconds. Accuracy is way higher because the answers are always grounded in their own internal data. And of course, the system is available 24/7. This isn't just a small improvement, it's a massive leap in efficiency.
And this brings us to a final thought. We've just seen how to make a company's data searchable and intelligent. But what comes next? I mean, what happens when these systems become proactive? When they're not just answering our questions, but they start anticipating our needs and solving problems before we're even aware of them? That is the future that we are building today.